Welcome to Cosmos in a Pod Space and Astronomy series.
Oh,
Today, we're diving into
uh-huh.
a period that's both mysterious and crucial
Right.
to our understanding of the universe,
Yeah.
the era of the first galaxies.
First galaxies, yeah.
Can you imagine a universe with no stars, no galaxies, just vast stretches of cold hydrogen gas?
It's hard to imagine.
That's where we're starting our journey today,
Wow.
back in the cosmic dark ages.
It's a time that really captures the imagination.
Yeah.
This period of darkness after the Big Bang's initial burst of energy.
Mm.
It might seem counterintuitive,
Yeah.
but this darkness is actually the starting point for the universe as we know it.
So we have this dark, quiet universe.
Yeah.
What happens next? I mean, how do we go from this cold, empty expanse to the dazzling star-filled universe we see today?
Well, the key player here is gravity.
Okay.
Even though the universe was dark, gravity was relentlessly working behind the scenes.
Uh-huh.
It started pulling together those scattered atoms of hydrogen gas, forming denser and denser pockets.
So it's like a cosmic snowball effect.
Exact.
The denser these pockets became, the stronger their gravitational pull, drawing in even more gas.
Exactly. And as these pockets grew,
Yeah.
they eventually became so dense and hot that something incredible happened.
What?
The first stars ignited.
Oh, wow.
These weren't your average stars, though.
So what were they like?
These were colossal giants, hundreds of times more massive than our sun.
Wow. Hundreds of times bigger than our sun. That's almost impossible to grasp.
Yeah.
What were these monster stars like?
They were truly remarkable objects.
Okay.
Imagine a star made almost entirely of hydrogen and helium, the simplest elements in the universe.
Right.
No heavier elements like carbon or oxygen,
Oh!
because those hadn't been created yet.
So these stars were like the universe's firstborns, made from the most basic ingredients.
Exactly. And like many firstborns, they lived fast and died young, burning through their fuel at an incredible rate. But their deaths were just as spectacular as their lives.
Oh, so.
They exploded as supernovae,
Wow.
seeding the surrounding space with the heavier elements they had forged in their cores.
So we have these massive stars exploding, creating heavier elements. But how do we get from these supernovae remnants to actual galaxies?
That's where things get really intriguing.
Okay.
Those heavier elements, scattered by supernovae, played a crucial role.
Okay.
They mixed with the existing hydrogen and helium, enriching the clouds of gas that were swirling around in the early universe. These enriched gas clouds became the building blocks for the first galaxies.
So it's like each supernova was adding a bit of seasoning to the cosmic soup, making it richer and more complex.
I love that analogy.
Thanks.
And as these enriched gas clouds continued to collapse under gravity, they started forming stars at a furious rate.
Oh, okay.
But there's another crucial ingredient in this galactic recipe.
Okay, what's that?
Dark matter.
Dark matter. The mysterious stuff that we can't see,
Right. Yeah.
but know must be there because of its gravitational effects.
Precisely. Dark matter formed these vast halos,
Uh-huh.
invisible scaffolding that helped pull in the gas and shape the first galaxies.
So dark matter acts as a kind of cosmic shepherd,
Yeah.
guiding the formation of these early galaxies.
That's a great way to put it.
Thanks.
And the fascinating thing is that we can observe these early galaxies today
Really?
thanks to powerful telescopes like Hubble and James Webb.
Wow.
We can peer back billions of years and see these infant galaxies as they were just a few 100 million years after the Big Bang.
That's incredible. It's like having a time machine that lets us witness the universe's baby pictures.
Yeah.
What do these early galaxies look like compared to the majestic spiral galaxies we see today?
They were much smaller and messier, like
Yeah.
cosmic building blocks. They were constantly colliding and merging with each other, gradually growing larger and more complex over time. It's like the early universe was playing a giant game of cosmic bumper cars, with these proto-galaxies smashing into each other, merging and growing larger with each collision.
So our own Milky Way, the grand spiral galaxy we call home,
Yeah.
probably went through this chaotic smash-up phase in its early years.
Absolutely. The Milky Way, along with most of the large galaxies we see today, likely formed through this hierarchical merging process. It's a reminder that even the most majestic structures in the universe have a messy, chaotic past.
That's kind of humbling, isn't it?
Yeah.
To think that our galaxy, with its hundreds of billions of stars, started out as these small, scrappy clumps colliding in the dark.
It really puts things in perspective, and
Yeah.
it highlights the incredible power of gravity over cosmic timescales. But there's more to the story of these first galaxies than just their formation. They also had a profound impact on the evolution of the universe as a whole.
Okay, I'm intrigued. What kind of impact did these early galaxies have?
Well, for one thing, they ended the cosmic dark ages. Those first stars, even though they were short-lived, emitted enormous amounts of radiation.
Uh-huh.
This radiation interacted with the cold hydrogen gas that permeated the universe,
Right.
stripping electrons from the atoms and ionizing the gas.
So these first stars acted like cosmic lighthouses, illuminating the universe and transforming it from a dark, opaque fog into something transparent.
Exactly. It's like someone flipped a switch and suddenly the universe became visible. This process of reionization was a turning point in cosmic history, marking the end of the Dark Ages and ushering in the era of light and galaxies.
That's pretty mind-blowing. It's amazing to think that those first stars born out of darkness played such a crucial role in shaping the universe we see today.
And their impact goes even deeper. Remember those supernova explosions we talked about?
Yeah.
They didn't just scatter heavier elements into space.
Mhm.
They also injected vast amounts of energy into the surrounding gas, heating it up and influencing the formation of subsequent generations of stars.
So those early supernovae were not only creating the building blocks for planets and life, but also stirring up the cosmic cauldron, influencing the evolution of galaxies.
Precisely. They were key players in shaping the structure and dynamics of the early universe.
Wow.
But there are still mysteries surrounding these first galaxies.
Like what?
One of the biggest puzzles is how supermassive black holes formed so early in the universe's history.
You mentioned those earlier.
Yeah.
Those monstrous black holes that lurk at the centers of most galaxies, including our own Milky Way.
Right.
What's the puzzle there?
Well, we see these supermassive black holes in galaxies that existed just a few 100 million years after the Big Bang. But according to our current understanding of black hole formation, they shouldn't have had enough time to grow that massive so quickly.
So it's like finding a giant redwood tree in a forest that's only a few years old.
That's a great analogy. It just doesn't seem possible given our current models. It suggests that either our understanding of black hole growth is incomplete or there's something fundamentally different about the early universe that allowed for the rapid formation of these supermassive objects.
So it's a bit of a cosmic mystery.
Absolutely. And a fascinating one at that. Astronomers are actively investigating various theories, trying to piece together how these supermassive black holes emerged so early in the universe's timeline.
It seems like every time we answer one question about the universe, we uncover two more mysteries. It's enough to make your head spin. But speaking of mysteries, we've talked about dark matter as this invisible scaffolding for galaxies, but we haven't really delved into what it is.
That's because dark matter is one of the biggest enigmas in modern physics.
Yeah.
We know it's out there. We can see its gravitational influence on galaxies and galaxy clusters, but we haven't been able to directly detect it or figure out what it's made of.
So it's like we know the universe is playing a cosmic game of hide and seek, and dark matter is winning.
Pretty much. And to make it even more intriguing, dark matter makes up about 85% of all the matter in the universe. That means all the stuff we can see, stars, planets, galaxies, it's just the tip of the cosmic iceberg.
That's incredible, and a little unsettling to think that we're surrounded by this invisible dominant force that we barely understand. It makes you wonder what other secrets the universe is holding back.
It definitely keeps things interesting. But even though we can't see dark matter directly, we can study its effects. Scientists are using a variety of techniques, from observing how light bends around galaxies to building ultra-sensitive detectors deep underground, hoping to catch a glimpse of these elusive particles.
So it's a bit like trying to understand the wind by watching how it moves the leaves on the trees. We can't see the wind itself, but we can see its effects.
Exactly. And with each new observation, each new experiment, we're getting a little closer to understanding the true nature of dark matter. It's a fascinating pursuit, and who knows what breakthroughs lie ahead.
It's amazing to think that these first galaxies formed so long ago are still teaching us so much about the universe today. They've given us clues about the formation of stars, the role of dark matter, the evolution of galaxies, and even the nature of black holes.
It really underscores how interconnected everything is in the universe, and it highlights the incredible power of astronomy, the ability to look back in time and witness the grand unfolding of the cosmos.
Well said. It's been a mind-expanding journey exploring the era of the first galaxies. And it leaves me with a sense of wonder, but also a burning curiosity to learn more.
That's the beauty of science. It always leaves us with more questions than answers, but it's those unanswered questions that drive us to keep exploring, to keep pushing the boundaries of human knowledge.
And on that note, we've reached the end of our cosmic journey for today. A huge thanks to you, our listeners, for joining us on this deep dive into the first galaxies. If you enjoyed this exploration of the early universe, be sure to follow and subscribe to Cosmos in a Pod for more space and astronomy adventures. And don't forget to check out our YouTube channel for incredible visuals related to today's episode. Until next time, keep looking up and stay curious.